All right, welcome back. We're just going to we're going to do some examples now, integrating exponential functions. So our rule is written out there for you. That was from the previous video. Feel free to go back and watch that if you need to. In terms of integrating exponential functions, actually doing some important things to look for. E to the f of x here. So if we consider this, what's significant is this f of x, this is f dash x out the front. So we always need to get our integral in this form. So we're always going to do a little bit of manipulating, a little bit of massaging to get f dash x out the front. In general, this here will not change. So you can't really do a whole bunch to change this. Sometimes you can. For harder questions, they might make you change that a little bit. But for now, just trying to get f dash x out the front, given f of x in here. Taking some examples, starting off nice and basic, let's just integrate e to the x dx. And this is just a standard example here. That's going to get you e to the x plus c. Okay, if we took an example b, did the same thing with a constant out the front. So if you had something like the integral of 4 e to the x dx, that's the same as 4 times the integral of e to the x dx. So that's going to get you 4, and that's going to be e to the x plus c, which you can make 4 e to the x plus 4c if you would like to. It will not actually make a difference. You might see some teachers, students, instructors write the answer as being 4e to the x plus c. It doesn't actually make a difference. I just thought because we had the 4 out here, the integral will be e to the x plus c. I had to multiply the 4 in, but it doesn't make a big difference. It does mean between here and here, though, you would get a different value of c. This one here would be a quarter of that one there. So the factor of 4 will play in actually generating a value of c. Not really important now, example-wise. Grabbing something a little bit more substantial. So if we take an example c and we integrate, and let's integrate e to the 4x plus 1 dx, so integrating with respect to x again. Now this is what we talked about when we talked about the example. We said if this is f of x, we need to get f dash x out the front. So f dash x, differentiating that will be 4. So we need to get a factor of 4 in here. To cancel that, I'm going to divide by 4 out the front, put a 1 on 4 out the front. So evaluating my integral then, the 1 on 4 stays out the front. That's not going anywhere in a hurry. Then evaluating the integral, this here, go back to the rule, that will be e to the 4x plus 1. Okay, and if you would like, you can put a constant here, or you can put the constant out the back. I'm going to put it out the back. It's not going to make a big difference. That's my answer. That integral there is 1 on 4 e to the 4x plus 1 plus c, or of course you can write that as being e to the 4x plus 1 on 4 plus c. It's not going to make a big difference for you at all. Moving on, taking an example D, I'm going to integrate the exact, I'm just going to integrate this. I'm going to integrate e to the 3x plus e to the minus 3x dx. So again, I'm looking to get that fudge factor at the front, that f dash x. Because there's two parts here, I can break the integral up, and here it will actually be beneficial to do so. So I can rewrite this as being the integral of e to the 3x dx plus the integral of e to the minus 3x dx. Okay, the plus from in there. You can do that term, you can integrate term by term. So you should have seen that when you did Introduction to Calculus in Year 11, but if you did miss that, and if it wasn't really helpful, well, now you can do it, and it's a bit more helpful, I think, in this case. Anyway, trying to get the f dash x's out the front. F dash x here would be a 3, so we need a 1 on 3 over here. F dash x here would be a minus 3, so minus 3 in there. We're going to divide by minus 3, so 1 on 3, and I'll make that a minus there. So working the integral through, this is going to be 1 on 3, e to the 3x. You can include the constant here or include it out the back. You don't need two constants. I know you're doing two integrals, but really you're only doing one integral. As long as there's a constant in there somewhere, get that c in there at some point. Minus 1 on 3. Then this is going to be e to the minus 3x, and then we'll add our constant in there. Okay, doing it term by term is not a bad idea at all. Lastly, we'll do a definite integral. You can also do volumes as well on this. Make sure you're using your volume formulas correctly. When you do that, you should have done integration at this stage if you're watching, anyone online. Definite integral, let's go the integral between 0 and 3, and we'll integrate, let's go, I don't know, e to the 2x dx. Okay, so again, looking for differentiating here. If that's 2x there, we need a f dash x out the front. We need it to be 2 because that differentiated is 2. Halve out the front to cancel that 2 out. So the question does remain unchanged as much as it's now achievable. This is going to be equal to then e to the 2x. Don't forget the half. And we're going between 3 and 0 here. Don't need a constant, it's definite integration. Make sure the half is out the front. I almost forgot that, you saw that. Then e to the 2x. So a half, and it's going to be then, it's going to be e to the 6 minus e to the 0, which is a half. Then it's e to the 6 minus 1. Okay. And if it was an area question, we'd be including units here, but we don't know if it's area per se. I would always advise keep coming back to the rules. Okay, you should be double checking this here, f dash x, for this here being f of x. Do a whole bunch. The pattern I think you'll find is the same for all of them. The more you do, the more confident you'll be. Yeah, get into it, do as much as you can. Hopefully these examples have been helpful for you. Thanks for watching. I think that's it. If you've got any other questions, let me know through email or on iLearn or whatever other ways you have of contacting me. Thanks for watching.